Welcome to Kcse Mathematics Revision channel. I am teacher James Marita, and today we are looking at some of the past Kcse questions on differentiation and of course integration. Most of these questions of differentiation are normally set either in paper 1, section P, or you can also have them in section in paper 2, in section P. So today we are looking at Kcse question of 2024. In 2024 we have this question: the gradient of a curve. We have been given the gradient of a curve. The gradient of a curve is equivalent to y is equals to px raised to power 3 plus 5x squared plus px minus 18. So from this question, we have been told that the gradient of this curve, here, where the value of x is equivalent to -1 is 15. So from this question here, we are supposed to find the value of p. How do you find the value of p from that equation here? We have been given to find the gradient of that curve at y is equals to px raised to power 3 plus 5x squared plus px minus 18. That gradient at the value of x is equals to -1 is 15. So how do you get the gradient? The gradient of a curve is normally given by dy dx. So we have dy all over dx. This one is giving us the gradient, and this one means we have to differentiate this one. So if we differentiate this one, we have 3 times 1 is giving us 3. Then we have x. This is 3 minus 1 is equals to 3x squared plus 5 times 2, we have 10. Then we have x, because we have this is 2 minus 1, and then plus 1 times p, we have this one as p. Since there is 1 here, 1 minus 1 is 0, and any number raised to power 0 is equivalent to 1. So it remains like that. And of course, this one here is a constant number. The derivative of a constant number is equivalent to 0. So the dy dx of that curve is equals to be 3x squared plus 10x plus p. But we have been told, remember, this one here is our gradient. This is the gradient here. But this gradient, the value of this gradient at where the value of x is equivalent to 1 is 15. So we are substituting two things here. One, we have been given this gradient as negative 15, and then we have been given this value of x as -1. So we have 3. Instead of now having our x squared, we have been told that that x is 1. So this one here is squared. Then plus 10 times the value of x, which is -1, plus the value of p. This one is equal to the gradient, and the gradient of that curve is given as negative. We have the gradient of that one is given as, we get it at -15. So if you can simplify on this side, you will have 7 plus p is equals to p minus 15. So the value of p is equals to p. You take -15. We have this one as -15, this one, and then we take 7 on the other side. It becomes a minus. We take 7 on the other side. So this one here we have as negative. This one is giving us -7, because -10 times -1 is giving us -10. Then plus this 3. So if we plus 3 here, we have this one as -10. And this one is giving us -7. So this one here is -7. So it closes to equal signs, it becomes a positive, and therefore the value of p is equivalent to p -8. So we have that value of p is equivalent to p -8. So that is it. So to get that one, you first differentiate. You differentiate dy dx, which is giving us as this one. Since we have dy dx, which is our gradient -15, we substitute -15 here. at x is equals to negative 1, where there is the value of x. Where there is x, you substitute by negative 1, and that one is giving us the value of p as negative 8. Then part p, we are supposed to get the equation of a normal to the curve at x is equivalent to 1. So we can write this equation here. The equation now, since we have the value of p, so we have y is equals to p. We have this is x raised to power 3 plus this is 5 x squared plus, now we cannot now be having our p, since we have our p as a negative 8, so this one it becomes a negative. So we have negative 8x then minus 18. That is how our equation looks like now. When the value of x is equals to 1, so when x is equals to p1 at x is equivalent to p negative 1, as we have been told here, the value of y is equals to p negative 1 raised to power 3 plus 5 into negative 1, which is squared, minus 8 into negative 1, then minus 18. So you will get that the value of x from the value of y here is equals to p negative. That one is equivalent to p. That one is equivalent to negative 6. So we have the points. Our points here, where the curve passes. It passes through point x is equals to p negative 1, y is equals to p negative, y is equivalent to p negative 6. And of course we have our gradient m1, m2. So we know our gradient here. Our gradient from this curve is negative 15. So the gradient of a normal to the curve becomes negative 1, this becomes positive 1. So we have positive 1 all over 15. Get that one very clear? Since we have the gradient of the curve that as negative 15, so the gradient of a normal to the tangent, that one becomes now the reciprocal of gradient 1, which is 1 over 15. So it becomes 1 over 15. So we have the 2 points here. So to get the equation of a line, you say that it's changing y, which is y, xy minus 6, so it becomes plus 6. Then you divide by, change in x minus 1, it becomes plus 1, and that one gives our grade is equals to the gradient, which is negative, which is 1 over 15. So if you go ahead and you simplify that, you will get that the equation of a normal to the curve, you will do your own simplification, and then you get that y is equals to p1 all over 15x, then minus 89 all over 15. So minus 89 all over 15. So you will do a cross multiplication here, and then you get the equation of a normal to the tangent of the curve is equivalent to 1 over 15x minus 89 over 15. What you need to understand from here is where we have the gradient of a curve, which is negative 15. So a gradient of a normal to the curve, is a reciprocal of that gradient 1. So we say that m1 gradient 1 is negative 15, gradient 2, because we can say that gradient 1 times gradient 2 is giving us negative 1. So we can get that our gradient 2 is equivalent to p1 over 15, and that one gives us the equation of a normal to the curve as y is equals to p1 over 15x minus 89 over 15. We are supposed to find the coordinates of the stationary point of the curve. How do you find the coordinates of the stationary points of the curve? The coordinates of the stationary points of the curve, there is one thing you need to understand here. At the stationary point of the curve, the gradient function is equivalent to 0. That means dy dx is equivalent to 0. So at this point here, we need to understand that dy, so we have dy dx, the whole thing here is equivalent to p 0. That now our 3x squared plus 10x 3x squared plus 10x plus now the value of p. The value of p was negative 8, now minus 8 here, and everything here is equivalent to 0, because at the stationary point, the turning point of the curve, the dy dx is equivalent to 0. So from here we have around 3 methods that we can use. You can use a complete square method to get the value of x, or you can use the quadratic formula to get the value of x. You can also use the P/S/F formula, that's the product sum formula. So since we have we can use our P/S/F such that our product is equals to P. The product is 3 times negative 8 is giving us negative 24, and then the sum is equals to P10. What are the factors now? Factors is equals to P. Two numbers which can give us a sum of 10x and a product of negative 24. So those numbers you will get them. This is the product. The factors are 12x, and then we have 2x. So we have 3x squared plus, sasa badala ya kuandika 10x hapa tunaandika 12x minus 2x. So we have this is 12x minus 2x, because these two here, when we find the sum of this one, our answer is equals to P 10x. Then minus, we subtract 8 there. So we group this one into 2 like that. Here we have 3x, then we have this is x plus 4, then minus, we have this is 2, and then we have this is x plus 4, and then this one is equivalent to 0. So from here we have this and this one, that is 3x minus 2 is equals to 0. From here you say that the value of x is equals to P 2 all over 3. Next we have x plus 4 is equals to 0. From here we conclude that the value of x is equivalent to P. The value of x is equivalent to P. The value of x is equivalent to P negative 4. Now that we have the two values of x there, that x is equals to P 2 over 3, or x is equivalent to negative 4. So at x is equals to P negative 4, what is the value of y? So we can start from here. X is equals to P negative 4. What is the value of y? You come part here where we have y is equals to P, x now is negative 4. So we have negative 4. This one is raised to power 3, like this one, plus 5. Then we have negative 4. This one here is squared, minus 8 into negative 4, then minus 18. So you will get that the value of x as negative 30. So positive 30. So this one here is giving us 30. So the first turning point, our first turning point in this case, the value of x is equals to P negative 4. The value of y is equivalent to P 30. We can proceed. When x is equals to P 2 all over 3, what is the value of y? At x is equals to P 2 all over 3, so x is equals to P 2 all over 3. What is the value of y? So we say y is equals to P. It is 2 all over 3 because we are substituting here. Then this one is raised to power 3 plus 5 into 2 all over 3. This one here is squared. Then minus 8 into 2 all over 3 minus 18. And therefore, that value of x is giving us negative 20, then 22 all over 7. So this one is giving us 20, then we have 22 all over 7. So the second turning point of the curve is equals to P. The value of x is 2 all over 3. The value of y is negative 20. Then we have 22 all over 7. Those are the turning points. The turning points of the curve. That is a question of 2024 paper 1 question 24. So the things that you are supposed to understand here, when you have been given the gradient of a curve, which is negative 15, the first thing you do is to differentiate. You find dy dx. Then where there is x, because we have been given the value of x as negative 1, so where there is x, the value of x as negative 1, you substitute there. Where there is 15, because the gradient function of the gradient is equal to 15, it will give us the value of p as negative 15. The equation of a normal to the curve. Here you use the principles of the perpendicular line, the equation of a line from form 2. Whereby, if we are talking about the equation of a normal to the curve, here is like we are talking about when the line which is perpendicular to that curve. So there is a line which is perpendicular to that curve, it makes an angle of 90 degrees. So you find the reciprocal of that gradient 1 is will give you as gradient 15 as gradient 2 as 1 over 15. And of course, getting the coordinates of the turning point, one thing you need to understand, at the turning point, the derivative, that is dy dx, is equivalent to p 0. Don't forget to subscribe to my channel, watch and share.